Okay, so with that, our focus today is going to be learning about two different ways of estimating the probability of harm. I like to start with the end in mind. And with that, what I mean is that we should understand the reason why we are doing this. And of course, most of you will say we are required to estimate risk. And part of the estimation involves estimating the probability of harm. Yes, that is all in clause 5.5. But to me, the real reason why we want to do it is in clause 10.3. Because in clause 10.3, ISO 14971 requires the manufacturer to review the information collected for possible relevance to safety, especially weather. And there are a couple of other requirements. I've just picked the one that is relevant for our conversation today. And we have to do that to figure out if an estimated risk arising from a hazardous situation is no longer acceptable. To me, this is the most important reason to have a good estimation of the probability of harm and a good estimation of the risk overall, because we want to be able to compare the change in the post-market phase to our estimated level to see if that estimated level still is acceptable or not. Because why? We need to take action. If it is no longer acceptable, we need to take quick action. And if our methodology that we are using for estimation of risk is not practical enough and not directly linked to our post-market information, we find that a little bit challenging, right? And I've seen that in practice. Numbers don't match. Whatever you have in your FMEA many times doesn't match with what the post-market data is telling you. And we are kind of just guessing if the risk has increased or not, if it is still acceptable or not. So what I want to share with you is the way I have implemented this in my practice using post-market information. So we'll go through that, and that's the reason why we want to do it, is to be able to have good intelligence gathering and good decision making during the post-market phase. So I hope that clarifies to you the context, the reason why we want to do this. And generally a risk matrix is used in the industry for risk evaluation, and I'm sure you guys have some form of a risk matrix, maybe a 5x5 matrix, which is the most common method, or maybe even a 3x3 or a 4x4. There is no requirement from an ISO 14971 point of view to use only a 5x5, but that is the most practical way. And this is how it looks like in my practice. I'm really in the favor of red and green, acceptable or unacceptable, not high, medium, low, not red, yellow, green. So I recommend to use only acceptable or unacceptable regions in a 5x5 matrix. Why? Because I think your decision making and data analysis becomes simple. So let's take the example of this individual risk, which is rated at a probability rank of 2 and a severity rank of 4. It's in green based on our acceptability criteria, whatever that might be. We're not going to go there right now, but it is acceptable. Now we have information in the post-market phase that tells us maybe the probability has gone to 4. We can immediately see that this risk has now moved to the red zone. Or alternately, we may think that the severity has gone up, and again, the risk has gone to red. So if we have a good way of analyzing the data in the post-market phase, either on a severity scale or on a probability scale, then we can immediately see if a certain risk has gone to the red zone or not, and we can take some action. And this is the context. Generally speaking, 1 to 5 levels are commonly used for both severity and probability of harm. For severity, you might have a scale going from 1 to 5 with negligible on one end and life-threatening to another end. And in between, you can fill that up with minor, major, and critical. Now, having said that, I'm sure you have probably defined what these levels mean in crystal clear terms, so there's no confusion, with some examples, right? That's how maybe you have set it up. Similarly, on a probability scale, you have 1 to 5 levels, starting from maybe improbable to frequent, and then you have the scale filled up with remote, occasional, and probable. You might be using different terminology, but generally a 1 to 5 scale is used. Now, unlike severity, for probability, we also define ranges for each of these levels because we want to be as quantitative as possible. Now, we don't have to be quantitative all the time. I would rather have good data and be quantitative than to be quantitative when the data quality is poor, right? So we have to judge the quality and quantity of data to use a quantitative estimate. But as much as possible, it is preferred to have a quantitative estimate. Now, just for examples, you might have ranges like these. Maybe less than 1 in a million is improbable, and maybe on the other side is a much larger number. And you fill the scale with different ranges on a log scale. That's what you do. And you might be using different ranges, but this is just an example. So this is how generally things are done in our industry. 1 to 5 levels of severity and 1 to 5 levels for probability. In addition, you might have numerical ranges for probability corresponding to each one of those 5 levels. Okay, so this is how we have set up. Now there are 2 ways of estimating probability of harm. The first one is the P1, P2 approach, which is described in ISO TR 24971. And generally speaking, this is how we understand how hazards lead to harm. Generally, there is an initial event or a trigger event, which is shown here, followed by sequence of events which lead to a hazardous situation and harm. So P1 and P2 actually split into 2 parts. P1 is probability of occurrence of a hazardous situation. As you can see, this will correspond to the sequence of events starting from the initial event. And then P2 is that once a hazardous situation has occurred, what is the likelihood or probability of that hazardous situation leading to harm? So these are 2 different probabilities. We have to treat them differently. P1 and P2 are 2 different concepts. The other approach is what I call a direct probability of harm approach, which just takes the number of harm events and divides that by the total opportunities. And we'll look at some examples. So these are the 2 different ways of estimating numerically the probability of harm.